Hello everyone. In this lesson, I will discuss how to use this raise and wire net, when to use and where not to use and when not to use raise and wire in Verilog. It is a very important topic and very important concepts from design point of view and also from interview point of view, because during the VLSI interview you will face this question, then what is the difference between raise and wire, and I will try to cover all the aspects of this raise and wire, their differences, how to use, where to use and when to use in Verilog in your logic design. Raise and wire specify means if you are declaring your signals raise and wire, then it specify how the object will be assigned and are therefore only meaningful for outputs. Okay, it is not meaningful for inputs. First thing is this raise and wire, this raise and wire is for outputs, that you have to remember. It is not for the inputs, because this raise and wire is used for assigning purpose, right? You are assigning some variables from right to left. Okay, so it is meaningful. First thing that you have to remember is it is meaningful for the outputs, okay, and not for the inputs. First thing you have to remember. Okay, if you plan to assign your output, okay, if you plan to assign your output in a sequential code, if it is a sequential design, and you know that sequential design means always block, we use the always block, then positive edge of clock, then reset, all these timing control statements are there, then we declare it as raise. The signals are declared it as raise, otherwise it should be wire, which is also the default one. Default one means, for example, if you have module, then some module name, then input, let's say input A and output B. So here the variables are, here the signals are A and B, and if you have not, if we do not mention anything, whether it is a wire or whether a raise type, this A and B, by default it is a wire. Verilog considers by default it as a wire type. Okay, so this is a default one. But if you know very well, then what you are going to do with your code and how the code will be converted into your real hardware, and if you are aware of those things, then definitely you will be able to use raise and wire. If it is a raise, then you are designing a sequential circuit, and if it is a wire, then it is either default one, or normally wires are used for combinational circuit. Raise is also used for combinational circuit. That one we'll learn. Okay, now if the signal is driven by assignments, see, if the signal is driven by assignment in a procedural block means a block beginning with always or initial, because you know there are two type of procedural block, one is always and one is initial, then it must be declared as raise. If you are doing any kind of assignment inside a procedural block that is always and initial, then the signal must be raised. Okay, that you have to remember, the signal must be raised. And if the signal is driven by continuous assignment means we use assign statement. Then, or if it is the output of a module instance, then it must be declared as wire. Okay, if it is declared inside, if the signals are assigned inside a procedural block, then you have to declare that signal as raise. And if there is a continuous assignment, or you are declaring something inside some signals in the output of the module instance, then it must be declared wire, or where it is the output without the range qualifier, or as an output without the range, means if it is simply, if you write output B, and if you do not mention anything, that is by default it is wire. Okay, a range signal must be physically the output of either. Okay, this one is important one. A raise signal must be physically the output of either LH. So if you are declaring a signal raise, then physically it can be the output of either a latch or a flip-flop. or of combinational logic. Means your range can be used, the range can be used for your sequential design, that is latch or flip-flop, or for combinational logic. So we cannot say that range is used. Range means never think that range means registers, and it is all because registers are sequential design. Okay, sequential logics, it is used for sequential logic, so it is always used for sequential logic. No, range can be used for your latch circuit design, flip-flops, or combinational logic. Okay, for example, there is a very common way of inferring a combinational multiplexer using always block. Inside the always block, it is not like that inside the always block whatever is written will be inferred to a sequential logic or sequential circuit. No, even if using this always block we can design a combinational circuit, and that time also we declare the signals are range as range. Okay, so we should not confuse ourselves that range means your sequential design and wire means combinational. No, range can be used for latch design, flip-flop design, combinational logic. Okay, a wire might be physically the output of a latch. See, range can be the output of a latch, flip-flop, and combinational logic, and wire also might be the physically the output of a latch, flip-flop, or combinational logic. So range and wires are both used for combinational logic and sequential logic. Okay, that one I will give you example. Okay, a real-time example I will give, both for range and wire, how they both can be used for sequential design and combinational design. Okay, next, in digital circuit domain, a wire will create a wire output which can only be assigned any input by using assign statement. And if you remember this one, when we write assign something, assign say y equal to a plus b, so this is what does that mean? If I write assign, means it just creates a port. Suppose for example it is a and b, this is the input port a and b. Then if I write assign y, then what it does actually, it creates a port, y port, and it just connects this one. It connects, so a plus b, so this is the adder gate, right? This is the adder gate. So it provides just a path, okay. So an assign statement creates a port or pin connection, and a wire can be joined to the port or pin. So this assign statement, if you write somewhere in your design assign, then it just creates a port, and as it is a wire, and if you declare this one as a wire, then it provides a physical path, wire. That's why it is called, this wire is called, why this wire is called wire? Because it is physically a wire, it is physically provides a electrical path. So it provides a path from this a plus b, means this is a adder, right? This is a adder, let's say this is a adder logic. Inputs are a and b, and output is, see, this is the output y. Okay, this is the output y. So it just provides a path, from a and b to this y after creating a port. So assign is creating a port, assign statement creates a port or pin, and this wire just joins them, like a normal wire, like a physical wire. Okay, and what this range is, range will create a register. Range means register, or it is a simple D flip-flop, which gets or receives inputs on basis of sensitivity list. Means for example, if it is always block, then if there is sensitivity changes, then we are assigning something to some variable. Then in that case, this range is simply like a register. Okay, so either it can be clocked on rising or positive edge of clock, or it is a combinational edge. Okay, so this wire is a physical path, or it is simple connection between two modules, or connection between two signals. This is a signal, this is a signal, and this is a simply a physical wire or physical path. Okay, and this range is like a register, and which can be clocked, on rising edge or falling edge, or sometime combinational. For example, see, if I write always at the rate pos edge of clock, if I write pos edge of clock, so what is this? Always at the rate pos edge of clock means it is triggered at positive edge of clock. But if I write always at the rate some signal a, then it is a combinational, right? It is a combinational edge. So it is triggered at some combinational edge, because it is not a positive or negative edge of clock. Okay, so it is simply a register, and I will give one example at the end, okay, for this one, for these statements. Okay, so you don't need to worry. Then this always block indicates a set of procedural instructions which happens in order they are written. We know very well that whatever is written inside the always block, because this is a procedural block, so the way it is written, it is executed in that manner. Okay, so the always block indicates a set of procedural instruction which happens in the order they are written. So reg data type hold on to its value while rest of the always block is executed. Means, for example, here y equal to let's say a, then z equal to b, and p equal to q. Then what happens? Let's say these are because the way it has been written, it will be executed in that way. So once so when some of the statements are being executed, so the previous statement holds those values, and to holding those value, what we use, because that we need a memory element, right? To hold the previous value, or to hold a value, we need a memory, and in that case, reg is just a register. This reg is just a register which is holding the previous value, or which is holding a value till all the execution are done. Okay, so this reg is kind of register, or kind of flip-flops, and this wire is a physical path, or a physical connection. So it completely depends on your use, whether you need to create a register and take it according to the sensitivity list, or you want to create a port or pin assignment. Okay, I am giving you an example for this one. Okay, let's see. So this is one example. See, this is this is one example. Okay, always at the rate edge of clock, positive edge of clock, then there is a case statement, select one, then some statements are executed, then end. Okay, see, it is this case statement, if we remember my case lesson, then if it is a case statement, it infers a multiplexer. Case in a Verilog, case means it is a multiplexer. Okay, so multiplexer is a combinational circuit. Okay, right? Multiplexer is a combinational circuit. If it is, let's say it is S0 and S1, inside this case it is S0 and S1, then definitely it is a 2-bit multiplexer. It is a 2-bit multiplexer. It is a 2-bit multiplexer. But here this is a sequential design, because we have a flip-flop is there, because clock is there, then multiplexer is there. How? If you remember this line, so it completely depends on your use, whether you need to create a register and take it according to the sensitivity list, or you just want to create a port or pin assignment. So what we have done here, it is triggered. It is triggered this logic, this multiplexer logic, the case statement for the hardware for the case statement is this one, this multiplexer. This is a pure combinational circuit. Okay, this is a pure combinational circuit, and this works very fine. But if you write always at the rate positive edge of clock, then what will happen? Every positive edge of clock, this case statement is triggered, because if there is no positive edge of clock, the case statement won't be executed. So now what we have done? So now we have included a sequential logic here. Now we have included a register. Now the whole circuit, as a whole, now it is a sequential design. This case statement inferred a combinational logic, but now the whole statement, the whole module, it inferred a sequential logic. So it depends, it is pure. That's why it is written. It only depends on your use. Okay, it depends on your use whether you need to create a register, because it was not necessary, right? It was not necessary to create this register, but you created it. So it is register or take it according to sense. So we designed that one with sensitivity list. And if you do not include this one, for example, if you do not include this line, so what is this one? It is purely a combinational circuit. So it is simply what we are doing, we are just creating a port and pin connection. And we are assigning this value, all this value, this select A and B to simply this out. Okay, so it all depends on your designer's choice, that whether how you are going to use that, how you are going to assign your output, whether it is a wire or whether it is a raise type. Okay, so here this combinational logic, this circuit, the combinational logic output latched on to one or more flip-flop at rising edge of clock. So this combinational logic, the output of this combinational block, there is a mux, it is latched to this flip-flop with respect to the positive edge of clock. Okay, then the next one is, so whenever inferring to sequential logic, and if there is a data to be held for some time, or if you want to store a data or hold a data, then normally that variables are declared as range. That you have to remember. Range means register. What does a register do? It is a memory element, right? Memory element means it stores a value. So if you need to store a value, if you want to if your logic or if your variables needs to hold a value, a previous value, or holds a value for some time, then you declare that variable or port as range. Okay, that range. And one of the this block is very, very important actually. See, this is the module, the in-out. You remember in-out means wire, so this is a net type. This module input is net type, because input is always wire. This is net type. The output can be net, output can be raised. That it depends. Okay, output can be net, output can be raised. So this is a module. Let's say this is a module. But if you are instantiating this module in another module, so you have this module. This small module is this one. If you want to instantiate this module in another module, so this bigger one is the module that where you are instantiating this part. If you are instantiating this part, then your in-out has to be instantiated. Your in-out has to be referenced to a net always. Means, for example, if it is a in-out, then inside your modules, let's say in-out A, input B, output C. So when you are instantiating this one, A, then B, then C. When you are this is A is the in-out, so this part has to be always a wire type signal. Okay. See, this is if it is a in-out, then the instance you have to instantiate that one to a wire. This is a wire type. If it is a B is the input, so it has to be wire type. Whatever you are going to instantiate, or whatever the signal will be there inside the parenthesis, it has to be wire type, net type. Okay, because it has to be a net type for input. Okay, input either for input either it has to be a wire type or it has to be raise type also. Okay, raise type also possible, either wire type or raise type. And if it is output, output, the output has to C is the output. So here it is either be a wire or it has be a raise for input. Okay, but for C means here it is the output. Okay, so for the output it has to be the instantiation has to be always net type. Net means it is a wire type. It is very, very important. Okay, let me give you example. So these are some of the rules that we need to follow for the wire elements. So when to declare the wire. Okay, so wire is normally a combinational logic. Okay, that you have to remember. Wire elements are simple wires in Verilog design. Already I explained this one. So these are some of the rules that you need to follow. Wire elements are used to connect input and output ports of a module instantiation together. So if you are instantiating something, for example here you are instantiating, okay, this is the module, and if you want to instantiate this one, then wire elements are used for connecting input and output. Okay, see this wire elements is this for input also. Input, if you are instantiating for the input, you have to connect to either a REG or REG type or a wire type, and for the output you have to connect, but for the output always it has to be a wire type. If you are instantiating your design, then this is the rule that you have to follow. This is the rule you have to follow. Okay, so wire elements are used to connect input and output. Here it is clearly mentioned. Okay, for input it can be REG type or it can be net type, means wire type for during the instantiation, but for the output, if you are instantiating this one, then it has to be always wire type. Okay, it has to be always wire type. Okay, then wire elements are used as inputs and outputs. So actual module, if you have a and inside the module the input is always net and the output can be net, means can be wire or can be REG. This is the statement 2 means. Okay, so wire elements, if it is a module, see this first one is for instantiation, module instantiation, and this is for your own module, and this is for module instantiation. This is a module. Okay, for the module, wire elements is used for inputs and it can be used for output also. Okay, wire elements must be driven by something. The wire elements is always driven by something, and it doesn't store anything. Means if you are not driving, then you cannot store that one. Okay, REG type it can store. For example, if you are assigning something, you are assigning y equal to a plus b. So this y is now a wire type. The y is a wire type. So unless and until you drive this signal, you are not going to store a value, right? You are not going to store a value, but you are assigning a value, right? You are assigning this a plus b value to y. So for that you need to drive that signal. So the wire has to be continuously driven by some signal. So this wire elements must be driven by something. So this is a wire elements, y is a wire elements, and it has to be driven by something, else it cannot store a value. So without being driven, it cannot store a value, because if you are not driving this value, you are not assigning this value, then wire is not going to store, because REG can store a data. REG can hold a data, but wire cannot store a data. It just assigned a value. So wire elements must be driven by something and cannot store a value. Unless until it is not driven, it is not going to store a value. Okay, then wire elements cannot be used. Okay, wire elements can, if inside a always block, left hand side cannot be left hand side cannot be wire type. For example, if it is always, and if you write a equal to b plus c, or if you write a equal to c plus d, okay, this left hand side cannot be wire. Inside a always block, the left hand side cannot be a wire type, it has to be always a REG type. Okay, and it is a non-blocking assignment. Okay, cannot be used a left hand side of an, it is a, see, this is a non-blocking assignment, this is a blocking assignment. You can write the blocking assignment, you can write a non-blocking assignment. Okay, both can be used, but the left hand side cannot be wire type. Wire elements are the only legal type. And if you are writing assign, if it is, see for example here assign, if it is assign, if you are writing assign y equal to a plus b or assign statement, then this left hand side has to be wire. The left hand side has to be wire. Okay, that you have to remember. Wire is similar to, it is similar to connecting a physical wires between pieces of hardware. So if there is a two pieces of hardware, if you want to physically connect these two pieces of hardware, then it is simply a wire. So it is a wire is similar to connecting a physical wires between pieces of hardware or a path for a signal to travel. Okay, so this is simple a wire. Okay, that you have to remember. Wire elements can only be used to model combinational logic. Okay, wire is used to model a combinational logic, that you need to remember. Okay, then legal uses of wire. So this is wire A B C D E. This is single 1-bit wide wires. So this is a 9-bit wide wires. This, if it REG y, assign A equal to B and C, that is what we discussed here, that left hand side, if it is assign, then it has to be always a wire. For assign statement is always wire, so it is a wire a. Okay, always at the rate b or c begin, I equal to b or c. The b and c can be range and wire. The right hand side inside a always block, inside a procedural block, can be range and can be wire, but the left hand side has to be always wire. Okay, see, this has the left hand side has to be always wire, and the right hand side can be range, can be wire. And then module instantiation, that we explained this one. Module instantiation, this output cannot be, this is out, okay, this is out and this is the input, right? This is the input of the module, and this is the output of the module. So when you are instantiating a module, then the output is always assigned to, always it is instantiated to, or it is always connected to wire. So this has to be wire, this E has to be a wire, but this D, it can be a wire or it can be a range. So D here we have declared wire, and here E is declared wire. If you remember this one, this input, this input is connected to either a range during module instantiation, or it can be connected to a net, means wire. But your output, when it is instantiated, it is connected to always a net type. It is always connected to a wire type, else it will show you error. Okay, that you need to remember. Okay, so this is module instantiation, and this is module instantiation, and this has to be, so this is input of the module. So this D can be either wire, D can be either range. Okay, but it is the output, so this E has to be always wire type, else it will show you error. Okay, then this is the rules for range element. So range elements can be used for combinational and sequential. That is what we saw here. It can be used for, see, for example here. So here, so this range can be used for both sequential and combinational, because inside always, if you write always at the rate asterisk, if there is no positive, let's say there is no positive edge of clock, and if you wrote simply asterisk, okay, means there are some signals are there in the sensitivity list, so you simply write either asterisk or A, B, select line. Then instead of writing pause edge of clock, if I write asterisk or AB or some signal, then it is pure combinational circuit. So inside the always we can write a range. Inside the always we can write range. Okay, but if you do not include the star or sensitivity list star AB or some signal, or if you write positive edge of clock, then definitely it is a sequential design, right? Positive edge of clock comes with sequential design, and if it is some signal other than positive edge of clock or some triggering signal, some sequential triggering signal, then it is a combinational circuit. So the range can be used for both. Range can be used for both combinational and for sequential design. That you have to remember. Okay, range are similar to wires but can be used to store information. Okay, it is wires means we are continuously driving that signal. If you are driving the signal and if you are not storing, then that time you have to use that one as a wire. That signal has to be wire. But if you need to store the data, or some state you are storing, like registers, like, so it is like it is a register. Okay, these are the rules. Register can be connected to the input port of a module instantiation. That is what we already did. So this input can be raise type or input can be wire type when we are instantiating. But if you are instantiating, the output is always a wire type. Okay, this is the first statements. Okay, range elements can be connected to the input port of the module instantiation, but not to the output port. Okay, range elements cannot be connected to the output port of a module. So when you are instantiating your module, so your output port cannot be connected to range, but your input port can be connected to range, can be connected to wire. Range elements can be used as outputs within an actual module declaration, but inside your module your output can be range, because inside your module this output can be range or it can be wire, right? See, inside your module, this is the module, this box is a module, so inside your module the output can be range type or it can be wire type. Okay, but if it is instantiating, if you are instantiating this module, then it is always connected to a wire. Fourth one, range elements cannot be used as inputs within an actual module. So your input cannot be range, because inside your module you cannot declare your input as range, because that is always by default it is wire type. Okay, inputs are always by default wire types. Okay, Range is the only legal types on the left hand side of always block. Okay, so if you are declaring some signal, or if you have some statement inside your procedural block, that is always block, the left hand side has to be always range. Okay, left hand side is always range, that you have to, means if it is always, and if you write y equal to a plus b, then this left hand side, this y has to be always range. Okay, range is the only legal type, else it will show you error. Okay, range is the only legal type on the left hand side of an initial block. So if there is any procedural block, like there are two type of procedural block, one is always and one is initial. So if you are declaring some variables inside, or if you have written some variables inside your procedural block, such as always and initial, then the left hand side has to be, always range. Okay, this is legal, because if you mention where, if you mention where this y, then it will show you error, it will give you error. Okay, range cannot be used on the left hand side of assign statement. Means if it is assign, for example assign, we already discussed this one, assign y equal to a plus b, this y is always where type. Okay, it cannot be range type. This is what this means, is this range cannot be used on the left hand side of assign statement. Okay, if you are using the assign statement, then this variables has to be always where type. Range can be used to create registers when used in conjunction with. So if there is always at the pos edge of clock, if you are including this positive edge of clock, means your triggering is with respect to the clock, then range is always a registers. This is what we discussed here, right? This is what we discussed here. If it is with respect to, if your logic is triggered, if your logic is triggered with respect to clock, then you will always get a sequential design, you will always get a sequential circuit. Okay, your hardware will be sequential. Okay, not combinational one. Okay, but if it is not there, if positive edge of clock is not there, means if it is some signal other than this, other than your triggering sequential triggering signal, like some clock signal or reset signal, or if it is a combinational edge, like some signal, random signal, then it is always a combinational logic. Okay, then range can therefore be used to create both combinational and this is one of the reason, and range can be used for both combinational and sequential logic. That is what we saw here. Okay, in this example, this is what we saw here. If this line is not included, always at the pos edge of clock, this positive edge of clock is not included, then it is a pure combinational logic. For example, if I write always at the rate, because it is a mock circuit, right? Let's say it is I0, I1, then some select line. If I write like this, and if I continue these statements, case statement, then it is a pure combinational circuit. But if I don't write this line, and if I include always at the rate, positive edge of clock, then this is a pure combinational sequential circuit. So range can be used. So range can be used for both combinational and sequential design, that you have to remember. Okay, and this is some rules, legal uses of range element. So this is where a, b, I, j. So range. So always at the rate a or b. So this has to be, because this is left hand side inside the procedural block. So this has to be always range type. Okay, using range left hand side all inside the always at the rate. If some statements are there, assigning statement, this has to be always range. Then inside initial begin, if some statements are there, that variable has to be range always. Okay, using a range in initial block. So initial block and always block, the assignment statements, the variables has to be always range. So this is also a always block. So this is a edge triggered one. Okay, this is a combinational triggered okay, this is a combination a or b. This is a combinational edge. Okay, this is a initial block, this is a edge triggered range, this is edge triggered. So this has to be range, this has to be range, and this has to be range. Okay, because these are the signals that has been included inside a always block. Okay, so this is one of the important statements. The range doesn't necessarily correspond to physical registers. Okay, they represent data storage elements. You have to always remember that this range always represents data storage elements in Verilog. They return their values till next value is assigned to them. means to store a value, or to hold a value, range is used. Okay, they can be either synthesized to, so a range can be range, if you have included this range type variable, then, and if you synthesize such codes, then it can be synthesized to a flip-flop, or it can be synthesized to a latch, it can be synthesized to a combinational circuit, and it may not be synthesizable. That you have to remember. You cannot say that if you have included range means it will always be a sequential design. No, it can be a combinational circuit also, and if you are synthesizing that one, it can be synthesized to, or it may give you a hardware of flip-flop type, or latch type, or combinational circuit, or it may not give you any such circuit also. So range is definitely synthesizable one, but if you are not following the coding guidelines, then it may not be synthesizable. Possibility is there. Okay, when wire and reg elements are interchangeable, so when we can interchange wire and reg, okay, both can appear on the left hand side of assign statements, always at the red block, okay. Wire and reg elements can be interchanged where, so this reg and wire, they can, so see, for example, always at the rate, when we write y equal to a plus b, this y is always range type, right? This y is always range type, but this a and b, it can be range type, it can be wire type. Okay, so they are interchangeable. A and b both can be wire, both can be range, one can be range, one can be wire. So right hand side can be wire, can be range, but left hand side has to be always range type. Both can be connected to the ports of a module instance, input ports module instantiation. Okay, when you are instantiating a module, so this input can be connected to either range or either wire. If you remember this one, when you are doing module instantiation, the input is either connected to range or either connected to wire. Okay, then this is one of the example. Okay, module net AB, input AB, wire net. So this assign, because we know that assign statement we always use wire, so this is a wire type. Okay, this is a wire type, and if you synthesize this one, this will give you the hardware. Okay, this is the hardware for this one. Okay, the corresponding hardware for this code is this one. So this is a pure mux. Okay, it is a mux. Two muxes are there. So if a equal to 1, see, if a equal to 1, then you will get your net equal to 1. If a equal to 1, then this one you will get this value, wire equal to this one. And if it is 0, if a equal to 0, means this line will be activated. If this line will be activated, then it will check for b equal to 1. If b equal to 1, then 0 will be propagated. This 0 will be propagated to net, else the x will be propagated to this one. So we are not storing here, we are not storing any data. You are simply, it is a physical connection, it is a physical port to port connection, right? It is a physical path, it is simply a wire. So no need to declare range here, simply wire is enough for this one. Okay, so it is a pure combinational circuit, and if you are declaring wire here, so it will give you a combinational hardware, or combinational circuit. Okay, so this is synthesized to this hardware. Okay, so if you write this way, okay, now range equal to register. Okay, this is range equal to register, always at the red star. Means it is not a sequential. Okay, it is a triggering signal, means A B. It is a star, means it is here A and B. If a equal to 1, then register equal to 1B1. So if a equal to 1, this will be assigned to this one, this will be assigned to 1, so register will get one value, if a equal to, else if b equal to 1, means this one, b equal to 1 means this one, else means a equal to 0. So now it is a equal to 0 now. Okay, if a equal to 0 and b equal to 1, so b equal to 1 now, else b equal to 1 and a equal to 0, means this one will be assigned to this one. So register equal to 0, else there is no else here. Then if b equal to 0, then what will happen? If b equal to 0, because we have not mentioned here b equal to 0, if b equal to 0, then what will happen? If b equal to 0, then what will happen? It will store the previous value, so since it is not mentioned what should be the value of register when a equal to 0 and b equal to 0, so what it will give? The register, this register will hold the previous value. If it is holding the previous value, then definitely it is a memory element. It is a pure combinational circuit, right? it is a pure combinational circuit, but because we have not included else here, else part, we have not included else part, so what it is doing, if b equal to 0, then whatever the register value before that, whatever the value that register had before, that value will be stored for b equal to 0. So for b equal to 0, it will give the register previous value, whatever value it had. Okay, so that means it is storing a value, it is holding a previous value. Holding a previous value means, see, this is when b equal to 0. So the register, it had some value register, so now it is a feedback path. It will provide a feedback path to this one, this 0. So this register, from the register there will be a feedback path, and it will be connected to simply this line, this one. Okay, so what is this one actually? This one is feedback path, and it is storing a value, means it is a simply a memory element. It is a memory element, but it is looking like a multiplexer. It is looking like it is a multiplexer. It is a it is a one. This is one multiplexer, this is one multiplexer, but now it is storing a value. So now this is sequential design. So REG can be used. This REG can be used for both sequential and both combinational circuit, because now it is not a combinational circuit, because in a combinational circuit, if you remember, there is no feedback path. The feedback path is only possible in sequential design. So now it is a memory element, and now it is a memory element, so now it is a register. It is a pure register, means it is a sequential logic now. Okay, there is no clock, definitely there is no clock, but it is a sequential logic. And so this is a synthesized, this is the real this is the hardware for this one. We have not included a clock here, but still it is a memory element. Okay, this is how it works actually. But if you include this single line, everything is same. See, all the codes are same here, but we are including a single line. If you include this single line, then it will be a pure combinational circuit again, because this register 1 bit, this is a default one, so it will store this register equal to 1B0 when there is no, if you want to include else if you want to include else register equal to 1 bit 1, if you want to include this way, then it's okay, because we have not included else. This is a coding guidelines actually. When I will be explaining you about the coding guidelines in one of my lesson, then I will explain how this, if you miss a else, then what happens. So you are missing else here, and we end up with sequential logic. So what we did here, we included one line, this register equal to 1B0. So whenever there will be this b equal to 1 register will give 0 value, and else what it will give? It will give this value. If b equal to 0, register will get 1 bit 0. So there is no feedback path here. There is no feedback path, and there is no feedback path means it is a pure combinational circuit, and it is a multiplexer. Okay, it is a multiplexer. So this is how you have written the code. It matters actually. It is not like that whether you use REG, or REG means your register, and REG means your always sequential logic, and WIRE means combinational logic. No, REG can be a sequential, REG can be combinational. Though it matters the way you have written the code, means whether you followed the proper coding guidelines. If you have followed the proper coding guidelines, then definitely you will get the real hardware. Okay, so you should know what you are designing. You should be aware of the things, that how your designing should look like, how the hardware should be. Okay, so it is all about this REG and WIRE, and it is a very very long video, and thank you so much for watching this video. And if you like the content, then please do like, subscribe this channel, and thank you so much.